Hi, my name is Kristina Martinez. I am a senior at Hathaway Brown, and for my Strnad project, I built a 3D printed gesture-controlled robotic arm. What inspired me to do this project actually came from when we were in quarantine last year and were required to socially distance ourselves. During this time period, I realized that tasks that were originally very simple were quite difficult to complete, such as the occasional chemistry lab in which I now had to do in line instead of in person. Not only was it difficult to do the lab, but it was not quite accurate as to how I would do it in real life. I wondered, what if a robot could do these tasks for us from afar while we simultaneously perform the exact same task? This served as an inspiration for my project, to create a gesture-controlled robotic arm using a 3D printer. On the internet, I found a video as well as instructions by Eben Kuo on how to make a 3D printed gesture-controlled robotic arm. The first stage in my project was using the models made by Eben to print out each part that I needed. This step seemed relatively simple at first, as the 3D printer, as shown here on the left, seemingly did all the work. What I didn't realize was that the machine had to be fine-tuned every single time it was used. What I mean by this is that I had to adjust the distance between this thing, the bed, and the extruder, which is this thing right here. And I would do so by adjusting these fine tuners right here and here. Additionally, bigger parts often took longer to print. Parts like this one right here, and you can see how big it is compared to my hand, took about 9 hours to print. At the end of this stage, I had printed about 40 parts for both the arm and the glove, and each part took about, well, ranging from 2 minutes to 14 hours to print. The next stage in my project was to wire up the glove. The glove is used to detect movement from the user and will then send data to the arm to act as intended. For the glove, I used an Arduino Nano, as shown in this image right here. In order to use the Arduino Nano with the breadboard, which is this white thing right here, I had to solder on pins for it to connect. Next, I wired in other components needed for the glove, including the Bluetooth, this thing right here, and the flex sensors as seen here in this video. Once everything was wired in, I could then plug the Nano into my computer as seen here and upload code. And so this video just shows how the glove looks like. Right now, there's in this video, there are a few loose wires, but that's just because I ended up not needing to use them, and so they really didn't serve a purpose. The third stage in my project was to wire up the different parts of the robotic arm using the Arduino Nano and the servo driver. The servo driver, this thing here and here, which is outlined by the blue box, allowed me to program each individual motor so that they can run independently. The servo driver was quite difficult to understand how it worked, because I had to code for multiple motors instead of just one. In the end, I was able to control all 6 motors as seen in this image right here. Now, if the motors were completely limp or not working, the arm would look like this, in which they're not moving at all, and it could be moved pretty easily. But as you can see in the image, I am just holding the base, and by just doing that and the motors are active, it's able to stand fully upright. Now in this video, I will show 2 motors being used, specifically this one right here and this one as well. I faced several challenges with this project. The first being that I had to change my original proposal, as I had originally planned to even incorporate haptic feedback, which ended up not happening. Another challenge was that when parts broke, 3D printed or hardware, I would either have to reprint or replace the broken parts, which led to wasting time to fix things and a waste of materials. A third challenge I encountered was that Eben's circuit diagrams were very intricate and sometimes not the most accurate. For example, sometimes wires that connected negative would connect to positive and it would not be good. An additional challenge was that since the wiring was so intricate, one slightest circuit disconnect could cause the entire thing not to work. The last challenge I faced was that there would be times when the code was too advanced to test out basic functions of the robot, and so I had to create new code in order to test making just several motors move instead of trying to connect the two parts together, the glove and the robotic arm. I would like to say thank you to everyone listed here on this slide, and I would like to say thank you for listening to my presentation.